Okay, so we are looking at proving identities. And the first one we're looking at is sine theta over tangent theta is equal to cosine theta. So when we're trying to prove identities versus when we are trying to simplify them, we need to prove that one side equals the other. So we're starting with the first thing we look at to see is which side is simpler. We want to find the more complicated side and prove it to the simpler one. Well, cosine theta is about as simple as we can get, so we know we're going to take our left-hand side to prove that. We're going to take the left-hand side, which equals sine theta over tangent theta, and first thing we want to do is write it in terms of sine and cosine. So we've got sine theta over tangent is sine theta over cosine theta. So we don't divide by fractions, we multiply by reciprocals. So we're going to change this to sine theta times our reciprocal of cosine theta over sine theta. Well, here our sine thetas are going to cancel, and that will leave us with cosine theta, which is equal to our right-hand side, which is what we're looking for. The second problem we're going to look at is going to be cosine u secant u over tangent u is equal to cotangent u. Now again, we want to pick the more complicated side, which is going to be the left-hand side, and I need to prove it to equal to the right-hand side. But the first thing I want to do is rewrite the right-hand side in terms of sine and cosine. So cotangent will be cosine u over our sine u. So this is what we're trying to get to. We know we want cosine, which we already have one, in the numerator, and we want sine u in our denominator. So we're going to take our left-hand side, cosine u secant u, divided by tan u, and we're going to write it all in terms of cosine and sine. So cosine u secant is 1 over cosine u, divided by sine u over cosine u. Well, as we go to simplify, this can multiply over. That'll get us cosine u over cosine u times, again, we don't divide by fractions, we multiply by reciprocals, which is cosine u over sine u. Well, cosine u over cosine u just cancels. It'll be 1. And then here we have our cosine u over sine u, which is equal to cotangent u, which is equal to our right-hand side. The next problem we're going to look at is going to be tangent u over cosecant u is equal to 1 over cosine u minus 1 over secant u. Now in this case here, neither side looks really simple, but this is actually going to become our more complicated side. I can rewrite 1 over secant u by taking 1 over secant u. We want to write things in terms of sine and cosine. This will be 1 over 1 divided by cosine of u. We don't divide by fractions, we multiply by reciprocals, and that will get me cosine u over 1, which is just cosine u. So this will really be equal to the negative, because of the negative sign there, cosine u. So again, I only got this in cosine u's, so I'm going to change this into the left-hand side of tangent u over cosecant u will be equal to the sine u over cosine u divided by 1 over sine u. Don't divide by fractions, we multiply by reciprocals. So that gets me sine u over cosine u times sine u over 1. Well, here I'm going to multiply, remember this is over 1. So sine u times sine u will get me sine squared u over cosine u. Well, sine squared u is equal to, with our Pythagorean identities, this equals 1 minus cosine squared u, still over our cosine u. Well, if I look at my original problem, I'm trying to get 1 over cosine u, and then if the cosine squared was over cosine, that would reduce down just to cosine. So I'm going to rewrite this and separate my fractions. So here, this is to the first power, so this will cancel out the squared part, which will get me 1 over cosine u minus cosine u, which will be equal to 1 over cosine u minus 1 over secant u, because we've already shown before that we can divide by that. So that will equal my right-hand side. The next one we're going to look at is we are looking at tangent of pi over 2 minus u is equal to cotangent of u. And in this case, with our pi over 2 minus u, we are looking at our addition and subtraction formulas. So here we have our s plus t parts, and that's what we're going to be using. The first part we want to do is figure out which one's the harder side, more complicated to start with. This will be the more complicated side. Cotangent u, we can just simply rewrite as cosine u over sine u. In this case, this is going to be our s and t when we're looking at our addition and subtraction formulas. So we're going to take our left-hand side again. Doesn't always end up being the left-hand side, it just happens to be. If this was in reverse order, we'd be doing the right-hand side. So we've got tangent of pi over 2 minus u. We're going to rewrite that tangent in terms of sine and cosine. So that's going to be the sine of pi over 2 minus u over the cosine of pi over 2 minus u. So with that, we are going to use our formula to reduce this down. All right, so sine pi over 2 minus u, according to our addition and subtraction formulas, will get us the sine of pi over 2 times cosine of u minus cosine of pi over 2 sine u divided by the cosine of pi over 2 cosine of u plus the sine of pi over 2 sine u. Now with that, we're going to simplify by using from our unit circle the values of our sine and cosine. So on our unit circle pi over 2, our cosine will be 0 and our sine will be 1. So sine of pi over 2 will be 1 times cosine of u minus the cosine of pi over 2 is 0 times sine of u, all over our cosine of pi over 2 is 0 times the cosine of u plus the sine of pi over 2 is 1 times the sine of u. Well, 1 times cosine u will get us cosine u. The 0 times anything is 0, so these two terms will cancel out because of 0 times 0 is 0. So if cosine u over 1 times sine u is sine u, and cosine of sine is equal to cotangent u, which equals our right-hand side, and we have solved or proven our identity. All right, the next one we're looking at is going to be the sine x plus sine of 5x over cosine x plus cosine of 5x is equal to the tangent of 3x. So as we look at this, this is going to be our more complicated side. But this side here I want to write in terms of sine and cosine so I know where I am headed with my problem. So in this case, we are going to use our sum to product. We have sums, we're trying to get to a product. Got addition, trying to get to multiplication. So these are our sum and product formulas. We're going to look for which ones we are trying to match. So sine plus sine, we'll get a sine plus sine right here. And cosine plus cosine will be this one right here. So using our sum to product formulas, we're going to again do our left-hand side is equal to sine x plus sine of 5x over cosine x plus cosine of 5x. And in this case of the formulas that we're using, this will be the x and this will be the y. So our formula says that we take on the top part, we're going to have 2 times the sine of our x plus y. So in this case, it'll be x plus 5x over 2 times the cosine of x minus 5x over 2 divided by 2 times the cosine of x plus 5x over 2 times the cosine of x minus 5x over 2. Well, these two terms here are exactly the same, so they're basically 1. Because it's all multiplication, we can cancel those out, and we can also cancel out our 2's. This will leave us with the sine. X plus 5x will get me 6x over 2 divided by the cosine of 6x over 2. This will be the sine of 3x over the cosine of 3x, which happens to be what we've reduced it down to in terms of sine and cosine, and this will equal the tangent of 3x. The last identity that we're going to prove will be the sine of x plus the sine of y divided by the cosine of x plus the cosine of y equal to the tangent of x plus y over 2. So, again, we're using our sum to products. And again, our more difficult side will be where the sum is. We're going to rewrite this as the sine of x plus y over 2 over the cosine of x plus y over 2. So we know how we are headed here. So again, sine x plus sine y, looking at our left-hand side, over cosine x plus cosine of y. So sine x plus sine y is going to be equal to 2 times the sine of x plus y over 2 times the cosine of x minus y over 2. And cosine plus cosine will become 2 times the cosine of x plus y over 2 times the cosine of x minus y over 2. And again, these two terms are going to cancel, and so will our 2's because they're exactly the same, top and bottom. So this will equal the sine of x plus y over 2 divided by the cosine of x plus y over 2. Sine over cosine will equal the tangent of x plus y over 2, which is equal to our right-hand side, and that is the way that you want to prove your identities. Get them in terms of sine and cosine in most cases to simplify them out.